With advances in technology, accelerator pedal position, or APP sensors, are becoming more common in the modern vehicle. Even though they are all similar in function, testing procedures will vary. Knowledge of these systems ensures accurate diagnosis. The information, procedures and schematics used in this video are typical of most vehicles. Confirm you have the correct information before commencing any diagnosis. This system enhances the operation of many other systems such as cruise control, traction control, electronic stability control and active braking systems. All passenger vehicles with APP sensors are required to have two separate circuits. This is a safety requirement as both signals are needed by the ECM to process the requested torque. If one or both signals are incorrect, a fault code will be set. The malfunction indicator lamp, or MIL, will illuminate and the vehicle will enter reduced power mode. There are two designs of sensor in use: potentiometer, or variable resistor, and non-contact. Both outputs are analog. This is due to a digital to analog converter within the non-contact APP. A 5 volt and low reference is sent from the ECM to the first sensor, while a signal return goes from the sensor back to the ECM. This signal will go to either a pull-up or pull-down circuit. A second sensor within the APP assembly has a separate 5 volt reference, low reference, and a signal circuit going to either a pull-up or pull-down resistor within the ECM. The signals will be of the equal rising, rising falling, or split rising type. To test any signal circuit, you will need to identify whether it's a pull-up sensing or pull-down sensing circuit. Not all wiring diagrams will supply this information. To do this quickly, connect the meter between each signal terminal on the harness connector and ground. A display of between 4.8 to 5.2 volts indicates a pull-up circuit. 0 volts indicates a pull-down circuit. This video covers codes P2123 and P2128, APP, signal voltage high, sensors 1 and 2 respectively. These codes are set by the engine control module when the signal from either sensor is determined to be higher than the maximum value for that circuit. Looking at the fault tables for pull-up and pull-down sensors, it can be seen that the fault will either be a short to voltage or open on the various circuits. It's good practice when testing all circuits associated with the APP sensor to record the voltage readings associated with each circuit. With the ignition off, disconnect the APP sensor. Using the appropriate wiring diagram, identify both 5 volt reference circuits on the harness side. They will commonly be called 5 volt 1 and 5 volt 2. With the ignition on and using a digital multimeter connected between ground and each high reference terminal in turn, test for 4.8 to 5.2 volts. Using the wiring diagram, identify the low reference terminals on the APP harness connector. Connect the multimeter to battery positive and each low reference terminal in turn. Record the readings as before. Terminal 16 of the DLC is a convenient source for battery positive when inside the vehicle. For a pull-up circuit, with the ignition still on, connect the meter between each signal circuit in turn and ground. Record the results. With the ignition on and the meter connected between each signal terminal on the harness connector in turn and battery voltage, record the result. Let's review our data. Observe the recordings. Both 5 volt reference circuits should be between 4.8 and 5.2 volts. Each low reference circuit should have indicated battery voltage. A correct pull-up signal circuit reading should display between 4.8 and 5.2 volts on each circuit. A correct pull-down signal circuit reading should display battery voltage on each circuit. If all circuits displayed the correct voltage and the DTC is current, then the fault can only be in the APP sensor. If any of the voltage readings were incorrect, then continue with the diagnosis. A short to voltage in either of the 5-volt reference circuits may cause these codes. This would be indicated by a meter reading on either circuit of 5 volts or more. With the meter connected between ground and the circuit under test, turn the ignition off and disconnect the ECM. If the meter still displays excessive voltage, then the fault is in the harness between the two connectors. Some vehicles have multiple harness connectors between the ECM and the APP. Be sure to locate all of these on a wiring diagram before performing these checks. To isolate the fault, disconnect each connector systematically while observing the meter. As soon as the meter reads 0, you have pinpointed the short to that section of harness. If by disconnecting the ECM, the voltage disappeared, then the short to voltage is in the ECM or another circuit from the ECM. To confirm which area is at fault, test between the affected reference circuit terminal at the APP sensor connector and all other ECM terminals for continuity. If the meter displays any reading other than infinite, then the short is in that circuit. If this test fails to produce any result, then the ECM has an internal short to voltage. An open in either of the low reference circuits may also trigger these fault codes. Begin by connecting the multimeter between battery positive and back probing each low reference terminal in turn at the ECM. If correct voltage is found here, then there is an open circuit between the ECM and the APP connector. Back probe any connector within the circuit to isolate the open. If, while back probing the ECM, correct voltage was not found, turn the ignition off, disconnect the ECM connector, and test for correct terminal tension or corrosion. Inspect the ECM terminals for damage or corrosion. If all is okay here, then the open is within the ECM. DTC P2123 and P2128 can also be caused by a short to voltage in a pull-down signal circuit or an open or short to voltage in a pull-up signal circuit. If a reading other than battery voltage was recorded, then this could indicate a short to voltage on that circuit. To confirm a short to voltage, move the meter lead to battery negative and read the display. Any voltage reading will indicate a short to voltage. With the ignition on and the ECM and APP sensor disconnected, test for voltage between each signal circuit and ground. If any voltage is displayed, then there is a short to voltage on that circuit. If there are any other connectors in the circuit, systematically disconnect each one while observing the meter. This will help isolate the short to voltage. If no voltage was displayed, then this will point to a short to voltage in the ECM or any circuit coming from the ECM. With the ignition off, APP and ECM disconnected, test for continuity between the APP signal terminal and all other terminals in the ECM connector. If any reading is displayed other than infinite, then the short is on that circuit. If these tests proved okay, then the short to voltage must be in the ECM. On a pull-up circuit with the APP sensor disconnected, 4.8 to 5.2 volts should be displayed on the meter when connected between the signal terminal and ground. Be aware that a short to voltage may give the same reading. We still need to confirm the circuit before continuing. Turn the ignition off and disconnect the ECM connector. Turn the ignition on and read the meter. If the voltage is still displayed, then the short to voltage is between the two connectors. Again, locate any connectors in the circuit and systematically disconnect to isolate the fault to one section of harness. If the voltage disappeared when the ECM was disconnected, then the fault lies within the ECM or any circuit from the ECM. Perform a continuity test between the suspect signal terminal and all other circuits in the ECM connector. If any reading other than infinite is displayed, then the fault is a short within the harness. If the continuity test proved okay, then the short to voltage will be within the sensor assembly or the ECM. Remember, before condemning the ECM due to an internal short to voltage, perform a resistance check across the APP sensor 5V reference and signal terminal. If the resistance is 0 or very close to 0, then the sensor has an internal short. Once the fault has been located and rectified, clear the DTC and perform the associated drive cycle. That's the diagnosis for APP sensor signal voltage high. When performing checks on multi-wire sensors, take your time, record your results and diagnose, don't guess. See you next time.